Hello, welcome to lesson 3 of our polynomial unit. In this lesson, we're actually going to be talking about graphing polynomials if I've already got them in standard form. Now remember from our beginning of our intro to the unit video, our main goal is to take a large polynomial, to factor it, which means break it up into parentheses, and then look at the graph. On Monday, we talked about how do we factor. We were talking mostly on quadratics, and so that was the topic we reviewed on that day. Tuesday, we talked about how do I graph quadratics if I've got the parentheses, and that's going to be a lot of the same concepts as we are going to talk about here today. Today we're looking at what happens if I have more than two parentheses, and we'll look at what are the steps for what are my x-intercepts, what are my y-intercepts, what are some other important points that I want to be able to find. And so the one main important thing that we want to know between quadratics when we're graphing in their factored form and polynomials are that x-intercepts are the same in either case. X-intercepts are always going to be the same thing as our zeros. What numbers can I plug into these parentheses and get 0? For a lot of them, that means we're going to be looking at the opposite. In the first parentheses, it's just the opposite number. I plug in -3, and that gives me -3 plus 3, which is 0. So one of my x-intercepts is -3. One of my x-intercepts is going to be 4. It's the opposite of the second one. And inside parentheses is always opposite land. The reason why, and what's going to help us with this last one, is because when I'm actually finding the opposite, I'm not really just finding the opposite. I'm finding what actually solves the equation that we're going to put over here of the parentheses equals 0. So in case of the third parentheses, what makes 2 minus 1 equals 0? Well, to solve this, we add 1 to both sides, we divide by 2. That's going to give us x equals a half for our third x-intercept, which I can also write as 0.5, comma 0. If you notice, every one of our x-intercepts has a 0 in for y. It's because I could go to my equation and plug in 0 for y and solve, and it will give me the answers that are my x-intercepts. On opposite, if I want to find y-intercepts, I want to know, well, what if I plug in 0 for x? And in this problem, if I go to my equation and plug in 0 for x and simplify, I'm going to get the answer of -24. Now, if you want to go to your calculator, verify that that's what it is. What we're doing is plugging in 0 for every one of these, doing the inside of the parentheses first, and then multiplying -2 times 3 times -4 times -1, and that gives me this answer right here. I'm not going to do all the steps on the board because we don't have a lot of time, but you can verify these on your calculator, and that's the answer that you should be getting. On our graph, because polynomials have some large output values, we want to make sure that we go from either -80 or -100 up to +80 or 100, because we're going to see a lot of big numbers that are going to show up. And while we don't have to have the points exactly, we have to have room to show all of those. So if you're doing this on your calculator, on Desmos, I would pretty much set it up to where you automatically have your y range from, let's say, -100 to +100. That way you'll be able to see good pictures when you graph it. If I plot all these points, I'm going to have -3 on the x. I'm going to have +4 on the x. And I'm going to have +0.5 on my x. And then -24 on my y. And my scale is where each line is by 20s. And so for me, that's going to be right about there. And that's going to make my graph a little bit easier to see. It's not going to be so drastically tall. Besides this, though, we need to figure out what else is going on. We've got some points, but the other thing that we did when we were looking at quadratics is we found what was in between those points. We found the vertex, which is the halfway point, and that helped us know if it was up here, that meant my u went down. If it was down here, that meant my u went up. And that was a lot of what we did to find the rest of our graph. Here, because we're going to see our graph going up and down, there's not just one point that we want to find. We want to find a couple of points. And it's also not one where we have to find exactly in the middle, because it's going to change depending on what our graph looks like. So what we want to do is we just want to find what is one point in between each of our x-intercepts and then on the outsides that's going to give us an idea of where our graph is going, up or down? What type of answer am I getting? So I'm going to look for, to the left of my farthest leftmost point, so I'm going to look for what happens if I plug in -4. Something in between these two values, and so for that I'm going to be plugging in -2, that's right here. Something in between these two values, and for that I'm going to be plugging in 1. And something to the right of my rightmost value, and the next one to the right is 5. So I'm going to use those x values specifically. You don't have to use the same ones that I do, but you always want to look for what is something in between each of your x values and on the outsides of your x values, because that's going to tell us the direction of where our graph is going. On your calculator, I would suggest you pause this for a second and take each of these, plug them into the equation, and see what you get. All we're doing is plugging in, let's say -4, and calculating each one. It will be a big number, but that's okay, because we're looking at a polynomial which has a lot of things that are being multiplied. So my four answers for these are going to end up being, if I plug in -4, I get 144. That's why we want to make our graph go up past just 10, because we already have some huge numbers that are showing up here. If I plug in -2, I get the answer of -60. If I plug in 1, I get +24. If I plug in 5, I get -144. Now these are some big numbers. We may not be able to plot each of them exactly, but what's going to be important for us is knowing whereabouts are these going to go. So the first one I'm going to skip because it's farther than my graph goes. So I'm going to look at the second one here. If I graph -2, -60, that point is right here. For the next one, if I plot 1, 24, that point's going to be up here. And it kind of gives us the idea that I'm going to have my graph is going to connect each of these points. And then it's going to be going back down to this and be going back up to this. And I want to be able to hit all of the points that I've graphed. The reason why we're finding the in-between points is I want to know between those two, am I going up between those two as like a hill, or am I going down between those two as a valley? And that's what these points let me know. Pretty much is letting me know if my graph is right side up or upside down. Is it above, in between those two, or is it below? One thing that's really important when graphing here, these x-intercepts that we found are our only x-intercepts. We're not going to have any other spot that our graph touches the x-axis, which is going to be important when we start looking at more complicated ones. From there, we see that on my farthest left, past -3, if I'm looking at my y value for -4, my y is 144, which means that once I get over here, my graph is going up, and it's going to go up there somewhere. If I look to the farthest rightmost number on my graph, I've got 4, and if I go over to 5, that means that my y value is all the way down to -144, so my graph is going to look like this. It's going down this direction somewhere. And this is the graph that we want to be able to look at and see whether I graph it on Desmos, my graphing calculator, or by hand. This is about what it will look like. Now, we're not going to get these perfect because some of the things that are kind of hard to find, like what's the maximum point here, that really only can be found algebraically by using calculus, and we're not going to get to that point. And so visually, we can kind of estimate where that'll be, but for the most part, it's just going to be try as best you can to find these main points, the x-intercepts and y-intercepts, and then find some list of points in between to see where the rest of our graph goes. We're going to do the same thing here on the second one, and we're going to talk about this. We have something a little bit different, which is that I've got whatever my parentheses are squared, and that will affect a couple of my different things. But what I would suggest, at least right now, is rewriting that as x plus 4 times another x plus 4 because it's squared. It's not going to change our x-intercepts, and it's tempting to actually go in here and try to square these numbers, but don't do that. Instead, what I would suggest you do is just write down x plus 4, another x plus 4, x minus 2, and x plus 1. That way you can just see, oh, I'm looking for 4 x-intercepts, and 2 of them are the same. Some of the stuff that goes on over here will help us understand what's going on in our graph. Right now, just know that if it's squared, write it twice. That means our x-intercepts are going to be -4, opposite of the first one, +2, opposite of the third one, because I've already got a second -4, and I've already got that written. I don't need to write it twice. And then -1, opposite of the third one. Those 3 points there are 3 x-intercepts, and on our graph, they go at -4, at +2, and at -1. Those are our 3 x-intercepts. Our y-intercept is where we plug in 0, and you can plug it into either one. Either of them will be fine, and you're simplifying and evaluating. This is where you actually apply the square, when we're plugging something in and calculating our answer. What that means is if I plug in 0 for x, I get the answer of 32. Go back, check my work if you need to. If you need to go in there and make sure that you know how I got that. That's plugging in 0 for x, and I get the answer of 32, which is right about here on my graph. Besides that, I want to find some points in between. So I want to find what's to the left of my leftmost number, so -5. What's in between -1 and -4, so let's say -2. What's in between -1 and +2, and that's going to be 1. And then what's to the left of +2, I'm going to use +3. And that's finding me a point in between each of my x-intercepts. Again, this is important because this will tell us if our graph is going up in between 2 of these points or down in between 2 of these points. If I think about these as x-intercepts, my graph is either going to go up and back to that point or down and back to that point. It's not going to be both, it's just going to be one. Those are kind of hard to see, but that's kind of our options here. We want to know which one it is. To figure that out, we calculate some point in the middle and decide if it's above or below our x-axis. So I do that, I use my calculator. I would suggest go to your calculator and verify these answers just so that you know you can find these as well. My 4 answers are going to be -28, -16, +50, and -196. I plug all these points in, and I'm going to have -5, -28, right about here. -2, -16, maybe right about there. 1, 50, which is up here. And 3, -196, which is down in this direction. And that part right there is a lot of, it's a long ways towards giving us what the graph is actually going to look like. Yes, technology helps. Yes, being able to go in there and find several points helps. But if I know my x-intercepts and at least one point in between, I know that if I go to the left of this point, it's going down because that's the direction of that point. I know that in between these 2 x-intercepts, my graph goes down because it's in between, and that's where my point goes. From there, my next couple of points are up, so I'm going to go up to connect the next 2, and my next one's going down because I need to go all the way down to -196. And that gives me a direction of my graph by just following these couple of points that I've graphed. If I don't do this, I'm going to get a lot of problems wrong because I'm not going to know, am I supposed to go and cross my line here or just bounce off my line? The thing that makes this different and the reason why this happens, now we're going to stick to this procedure right here, finding points in between. But the reason why this happens, why it bounces off at -4 rather than crossing at -4 like the rest of them, is because that was what parentheses we had squared up here. Actually, what's going on is we're drawing a little parabola at -4 because it's whatever squared, just like a parabola was. That pattern's going to show up every once in a while. We'll talk about that when I get back. But when we're graphing this, if we always look for points in between, we're going to be able to find our graph no matter what it looks like, no matter if it goes up, down, any direction that it could go.